Alright, hi everybody. This is a very short video just to introduce the idea of projectile motion, review some of the key concepts we talked about in class. What is a projectile? Well, simply put, a projectile is an object upon which the only force acting is gravity. So here we go. We have some kid who's dropping some object off of a cliff, and even though it's just falling, we've seen this problem before, we could think of that thing as a projectile, right? Because it is falling and the only force acting is gravity pulling this thing down, so therefore it's a projectile. Same with this guy. Once he throws this projectile up, the only force acting is gravity pulling it down. That slows it down and then brings it back down. Even if you were to throw it off to the side, the only force acting once he releases this thing is gravity pulling it down. You get this familiar arc to it. Now you're going to also see on our haiku page lots of other pictures that have the same idea. This actually comes right from your physics classroom textbook, but here we have cannon being fired horizontally off a cliff, so we get to see this thing fall, and it even draws the velocity vectors, which we're going to talk about here in just a minute. We could fire this cannon at an angle, so this projectile goes up before it falls down. There's a common problem where you have an airplane dropping cargo, and you can see, boy, this shape looks exactly like this shape, right? That's because it's essentially doing the same thing. It's falling and moving to the right at the same time. And this picture is a great one because it can kind of show you that, okay, if the car was stopped, the truck was stopped, it would just shoot the projectile straight up in the air and catch it again. But because both are moving to the right, you have this familiar projectile motion. So here's a nice picture. This is two golf balls in free fall, falling. This one here is just being dropped. This one's given a kick off to the side, like that demo we did in class. And you can see from these pictures that at each time interval, each ball is at the same point vertically, so they could even have the same shadow over on the wall, and you see what happens is they speed up. They're falling, gravity's pulling them down. But there is something unique if you notice that this golf, so first of all, that's crazy that these two are falling at the same rate. That means it doesn't matter how far I kick this thing over, even if it was a gun that shot the bullet this way, the bullet falls. Once it's in the air, it falls just like anything else, and both would hit at the same time. This also shows, you notice how this golf ball moves to the right at a constant rate. It has a constant velocity to the right, as we can see from the shadows down here. So this is kind of wild. This means that the X and Y motion of a projectile, they're independent of each other. They combine together to make the motion that you see, but each one can be treated independently. What's going on in the X doesn't affect what's going on in the Y, and vice versa. And that's what this little key idea is over here. So you'd always want to treat those separately. That's going to be a key point when we start solving problems. Here's another great picture. Shows something similar. Instead of just being kicked off to the side, here it is, a projectile being thrown straight up, or sorry, not straight up, but off to the side at some angle. And as it is, you can see the vertical stuff, you can think of it as the shadow of the ball on the wall, just goes up and down, just as if the kid had thrown the ball straight up. But down on the ground, if you were looking from the top down, what you would see is just this shadow that constantly moves to the right at a steady rate. And so what happens is you have a combination of velocity up and velocity to the right, and as you get higher, the velocity to the right stays constant, but the velocity up gets smaller, and then eventually you just end up with velocity to the right when you're at the top. And then it starts to fall, so it'll have velocity down and velocity to the right. Velocity down even more, velocity to the right, velocity down even more, velocity to the right, and these two vectors combine together to make the overall flight path of this projectile. So you can imagine drawing in sort of the vector sum arrows. That one wasn't very good there. That would follow the path of this red line there. So that's just a quick introduction. You can read in your text more about that, but now we're going to start